Hello there, math fans. This is Dr. Andy Lovelace. I'm going to talk about something I've kind of jokingly talked about over the years, which is there's three happy situations when people give me data about lines and planes. And I've been emphasizing this a little more because I think it helps students understand a few things. The three happy situations are when you have two lines that are parallel, so line and another line, and they're parallel. And I'll explain why we really like that. So if a problem says, assume you have a line that's parallel to this other line, then we're very happy. I'll talk about that in a second. Assume you have a plane that's parallel to another plane, then we're also very happy. So that would be plane, plane, parallel. Then we have one other situation that we like a lot, which is when we have a plane and a line, but not parallel, perpendicular. So if you have a plane and a line, and they're what we say orthogonal or perpendicular. So you might think for a second why I call those the happy situations. These three. Put a little smiley face there. The reason I say those are the happy situations is because if you look at the vectors that are important to those two lines, and you look at the vectors that are important to these two planes, and you look at the vector that's important to this line in this plane, they point the same way. Which means that if someone says, I want you to give me a plane that's parallel to this other plane, you can use the same normal vector. So what I mean by that is, let's say I'll give you a line here, y, z, 3t, 2 plus t, 7 minus 5t. And then I say, I want another line that's parallel to this line. You can use the same vector 3, 1, 1, negative 5. And then they just have to give you the new point. And say, well, I'd like it to go through the origin instead. Okay, no problem. So I call that a happy situation because look at how fast it was. We got to use the exact same vector here and here. That's because the two lines were parallel. So we like those situations. We like to recognize situations because we are done. If the question is to find the equation, same thing is true for a plane. So here's the equation of a plane. I've drawn it to the right. Oops, I think the one I drew actually has the 10 on this side. And someone says, okay, I want another plane, but I want it to, so I haven't even drawn it yet, but I want it to go through a different point. Let's say we want to go through the point 0, 0, 5. You can use the exact same normal vector, but the point we're going to use is 0, 0, 5. Done. So if I type that in, which I'm about to do, sorry I wasn't ready for this. I'm bumping my mic. Here we go. Oops, I think I changed one of my numbers. Doesn't matter. We'll still make this picture. There. Parallel. Not hard to generate. I use the same normal vector. I just changed the point. One of our happy situations. And the third one is this situation where, what if I wanted a line that's perpendicular to this? Now some students go, well, hold on, why isn't it parallel? Well, because the normal vector is perpendicular to the plane. And so if I wanted a line that was perpendicular to that plane, I could use the same numbers, 3, 2, 5, t, 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 plus, plus, plus. And then they would just have to give me the point, whatever that be. So I could say, I want it to go through the point. Let's use that same 0, 0, 5. Okay, let's draw that. Here we go. No problem. I just have to type in what I just said. So I want to go through the point 0, 0, 5. and I want to go in the direction of the normal. So the 3, 2, 5. And I want to draw that line. Oh, I got to give it a bigger range of values so that you can see it. And there it is. Those are our 3 happy situations. If someone gives us that information, we're essentially done. They've given us everything we need. They've given us the vectors we want. So what are the unhappy situations? These are the sad situations. Not sad, just not as helpful. Well, they would be the ones I didn't describe here. 2 lines that aren't parallel. So, for example, 2 lines that intersect or are skew. That might be harder information to work with. 2 planes that intersect. Or let's say there's one homework question that says 2 planes that are perpendicular, which feels like it should give us more information, but it doesn't. And I always tell students to look around the room you're in. Do you see any perpendicular planes? Look at the wall in front of you. Look at the wall to your left. Look at the ground. They're all perpendicular to each other. So just being perpendicular doesn't tell you a ton. It does give you one vector that's parallel to your desired plane, but that's not usually what we want. It's helpful in some ways. And then another one would be like, what if you have a line and you have a plane and they're parallel, meaning you never get closer. Those are the unhappy situations. Typically, that does not give you enough information to give an equation. All right, I find that helpful to sort of guide students' thinking. If you see 2 objects that are the same, a plane and a plane, and they're parallel, that's typically going to mean it's going to be easy to find the equation. If you see a line and a plane, then you're hoping it says perpendicular. All right, I hope that helps.